Okay, so let's get into it. So you guys already did this, so I should be able to rush through it and you guys will be okay. So there was a mix-up apparently. So the quiz you just got, you were supposed to be doing recitation, and I was supposed to do 5.1, but apparently there was a mix-up. But I want to know what you guys know, and I want to know what I told you, or I don't know what someone else told you. So we're just going to go over it again. We're going to go through it pretty quickly. Let's see what we can get through by the end of class. So we'll start again from 5.1, which is just area between curves. There's so many sensors in this room. Like there are these sensors that they click when I walk under them. So like being up here talking is so weird. I hear sounds all the time. Bing, bing. So funny. Okay. Okay. So tell me what you learned. How do you find the area between two curves? So let's say. So yeah, I don't have to write down all this other stuff because you probably see. Oh well, let's make sure. What's the geometric interpretation? Of something like, start there. How do you interpret that? Yeah?
It's the area under the curve with f of x between the points on that.
Okay, so f of x is some sort of function that we probably know the graph for. And if it's nice or integrable between a and b, then the area under the curve between a and b is given by this expression. It's called the definite integral. That's how we can interpret that. Now you already set this up as Riemann sums back in California, I assume, where they dissect this into rectangles and they came with forms to add the rectangles and use summation formulas to figure out a formula for this guy and all that stuff. So we won't really need that deep treatment here. Just you need to understand what this thing means. The area under the curve, under is in quotations because we can get negative area from this interpretation if the curve, for example, dips below the x-axis, right? So here you can get this guy gives the negative area, right? So we all get that. Okay, so now we can go to, what about two curves? So how say you notice, okay, so here's one formula, and here's another formula under it. Let's call that f of x and g of x. And I want to find the area between the curves between a and b. How would you do that?
You would take the integral from a to b of the top curve, which is f of x, and then subtract g of x.
And then subtract the area under g of x. And do we get the reasoning why that was the case? And so the idea is if you're under f, you get this whole thing. But if you're under g, you get just that part. And then if you take this and subtract that part, the part that's here, it's like you're subtracting it. You end up with the area that you want, right, which is the area in between. Okay? Yes?
Now, is it appropriate to put f minus g of, or could it be appropriate to put f minus g of x in one integral?
it is appropriate, and it's actually weird to write it as that, so I would actually do it as that. So this means a would be equal to the integral of a b of f of x minus g of x dx. And this happens by the addition property of integration. Right, so an integral actually distributes across a sum. Again, that's something you would have learned in Calc 1, and that's called the addition property of integration, or antiderivatives. Right? In fact, how do you conceptualize this? Do you memorize this in terms of f and g? How do you conceptualize such a thing? Give it to me as a quick thought bubble. So I say, find the area between two curves. What is it that you think I should be doing? What would go into your mind? Yeah.
The area of the upper curve minus the lower curve?
So the idea that I want you to take away, the intuitive idea, right? Because very few people think in terms of forms, walk around thinking of x and g's, right? The intuitive idea is the area between the curves is the integral of the top curve, or the upper curve, and you subtract the lower curve. Right? So there are two levels on which you want to memorize a formula or a concept, right? There's the mathematical definition and there's the intuitive definition, right? If you get too stuck on this, then if your professor renames the curves, it messes you up. I know a lot of people like that because they get so fixated on the particular variables and lose the concept that they're just like, if I use different notations, and it just messes them up. Right? They're used to seeing, oh, y equals f of x. If I tell them q equals p of t, oh my god, I don't know what I'm doing. Okay, so I want you to actually have the concept, right? The idea between curves is the integral of the upper curve minus the integral of the lower curve, or bottom to kind of. Right, so top minus bottom, right? That's a very important idea, and it's something that will come back in multivariable calculus when you're setting up iterated integrals. It's an important idea, which is why I sort of covered this. I decided to cover 5.1 again because it's an idea that you're going to be building on. A lot of things in calculus, especially when it comes to integrals, all are about relative positions. What's on top, what's on bottom, what's to the right, what's to the left. And you have to know about relative positions and how they play on each other. So when you're talking about the areas between curves, you can talk about the top curve minus the bottom curve. But there's another idea. And in Calc 1, you never really looked at this situation that much, I don't think. But now you're going to start looking at it, and in Calc 3, it's going to be crazy how many views you're going to have. But what if the curves were kind of weirdly defined another way? I want to find that area. But now my curves are functions of y. So let's say this is h of y, and that is g of y. What is the area between the curves now? Yeah?
The integral from c to d of, is that g of y? G of y minus h of y dy.
Right? So we're going to, in Calc 2, we're going to look a lot at the other perspective. So we're not always going to think of things as x as the input, and we're looking at rectangles going this way. Sometimes it is convenient to actually tilt your head and look at things this way, like the rectangles are being stacked on top of each other on their sides. And the views are called the dx, which means with respect to x, which means you're dissecting the x-axis, or you can have dy, which means you're dissecting the y-axis and you're looking at your limits from the y-axis. Okay? And when you're in Calc 3 and you're in 3 dimensions, there will be 6 different views. So it's going to be something you're going to get used to. In Calc 2, we'll only have 2, the x view and the y view. Okay? So that's one thing. So also, another concept you can look at is area is going to be the integral from c to d. And in this case, it will always be the right function minus the left function. So ignore the names aside, the particular formulaic definitions aside, it's either going to be right minus left or top minus bottom. It will never be the other way around. And that's the concept that you really want to stick with. Right? So if you're thinking in terms of y's, it's right minus left. If you're thinking in terms of the X view, it's top minus bottom. So in this case, I sort of told you what these limits were. I just said, okay, tell me what's between C and D. Sometimes we are not given limits, but rather they are defined by the curves themselves. So that could be something like this situation here. And you want to find the area between these 2 points here. And let's call that F. And so this would be something like they might use the phrase the area bounded by the curves. The situation we were looking at before was they say, what is the area between these curves between A and B? They gave you the numbers. But here they just might say, bounded by these curves, they give you 2 random curves. They don't give you any points to put on your integral. What that means is you have to figure out what those points are, and usually they're going to be intersecting curves. And you have to figure it out based on the intersections. Okay. What's the area between those curves there?
G of x minus f of x.
It's G minus F in this case. So A here is going to be A to B of G of x minus F of x. If, assuming that I can find these, A and B, in this case you need to find, you can have that sort of situation. Another situation is sometimes roles can change. There's another situation you have to be aware of. Okay, so sometimes you can say something, again, it's going to look the same. They're going to say find the area bounded by the curves. Say this is one function, f of x, and this is another function. It's now g of x. And this keeps going down, that keeps going up. This keeps going down, that keeps going up. How do you find that area? So this here. Yeah?
After you'd have to find that middle point, you have to find all 3 points.
So
of the
you'd have to find all the points of intersection.
and then swap them after the second one.
Right, so here there's the A, let's call that C. So A and B are the 2 outer ones, so let's call the middle one C. And so in this case, the area would be what?
Integral A to B, or A to C, sorry. F of x minus B of x, and then plus integral C to B, G of x minus F of x.
So situations can build on each other, they can get more complicated, but once you have that that thought in your head, oh, I need top minus bottom, then you realize if your top function switches, you actually need a whole other integral to deal with that, right? Because the integrals have to be set up in terms of top minus bottom. So these are things you have to consider. And of course, it could be that your curves kind of behave like this, and then it's better to set up integrals that way. So the time to be fixed to one axis it's over. And so C, D, E. And so here the area, let's say I call this F and that G. Let's say I call this F and that G. And the area in this case would be C to D of
G minus F,
G minus F
dy.
dy. Right? Which means all your variables should be y when you're plugging these. We'll do some examples, but I just want you to get the idea first. The area in this case is going to be what?
C to E of
If you do it with C to E,
F minus G
F minus G
dy.
dy.
And the second integral is E d of G minus F dy.
Okay, so we have the idea. So when you're thinking about what to integrate, what's the really deciding factor is the relative positions. Who's on the right, who's on the left, or who's on the top, who's on the bottom. Another situation that's very common that you might have to deal with is what's the best view? And of course the answer is, yeah.
Sorry.
Chris.
For that instance there, would it be g of x still or g of y?
G of y.
G of y. Okay.
So once you do, so if you do dy, it means your input variable is y.
Okay.
So
So,
all your functions you need to write them in terms of y's. The limits on your integral comes from the y-axis. Everything's going to be y's that you're putting down.
okay. But doing g of y solves for the x value then, right?
Well, it depends on how the functions are given.
Okay.
So when we do specific examples, you'll see. I just wanted to get the main overall idea, right? Because the specifics, they kind of fall into place when you're faced with a problem. But if you don't know where to start or you don't know what to do, it's kind of hard, right? But yeah, the functions can be given you in terms of any variable, but you might need to know, oh, it's better for me to do this dy, and then you will know I need to make sure I solve for all my functions in terms of y.
Okay.
Or if you look at the problem and you realize, oh, it's better for me to do a dx, then you look at, make sure all your functions are solved for in terms of x.
Okay.
So when you get specific, that's it. That's going to be the idea. But right now I want you to get the overall concept. It's going to be top minus bottom or right minus left. And in the situations where these switch roles, you need an entire new integral in order to solve the problem. Okay? And so now the question is, because I have both dx and dy, the question is which one is better? And the answer is it will depend. So let me give you an example where it might depend. I have a parabola, and I have a straight line. I want to find the error between those curves. So I'm going to call the parabola F and the line G. I want to find the error between those curves. Let's assume we know the intersection points. So let's say the first intersection is C on the y-axis, it's D on the y-axis, it's A on the x-axis, B on the x-axis. This is going to be C, D, B, sorry, A. Okay, so now the question is, how would you set up each of these scenarios? Find the error between the curves. What would you do here? Yeah?
For the first one, I do it in terms of x.
Okay.
Because if you did it in terms of y, you go from parabola to parabola. So you'd have to do two integrals there. And then for the other, you want me to start with the other one, or someone else to go?
Okay, so here the A area would be, let's set it up.
Okay. Integral from a to b of
Let's say f in terms of x, or g?
G, yeah, G of x minus f of x dx.
So dx is the better way to set up here, and this case,
Would be the opposite, for the same reason.
okay, but what would the,
So it would be from C to D. G of x.
G of y.
I meant G of
g
y.
of y, so,
minus
which,
f
this
of
is
y.
kind of an abusive notation, because technically g of x and g of y would be the same thing in theory. But you get the idea, I would solve for the other guy and write everyone in terms of the other variable.
dy.
So the dx would be the better way to do this one, and the dy would be the better way to do this one. And did everyone get the reasoning why? I need to make sure everyone understands why. Okay, so what's the main concept when you're talking about finding an area? What's the main concepts? What's the main ideas? Yeah?
If you wanna go from like the top curve to the bottom.
Top to bottom or
Or right to left.
right to left. So when you're looking for a problem and you want to know how am I going to approach this problem, that is where you start. Is it better to look at it as from top to bottom or right to left? Now if you're looking from this, from top to bottom, how would it look? Well, who's on top? G. For the entire shaded region, G is on top. And who's on bottom? The parabola. Okay. Now, could you say the same thing if you interpreted it right to left?
No.
Because what if you're over here, right? You're stuck in this shaded region. You look to your right, who do you see? The parabola. Look to your left, who do you see? The line. But what if you were down here? You look to the right, who do you see? The parabola. Look to the left, who do you see? The parabola. Notice that what's on your left changed, right? Which means if you're doing the right to left interpretation, you need two integrals to deal with the two different situations. You need an integral to deal with the situation where the line is on the left. You need another integral to deal with the situation where the parabola is on the left, right? So it turns out here, top to bottom is the better way to do it, because if I did right to left, I need two integrals as opposed to one. Okay? For the same reasoning here, if you're stuck in this shaded region, then you look to your right, it's the line. If you look to your left, it's the parabola. And it will be that case no matter where you are in this region. However, if you look top to bottom, it's a different story if you're on this side versus that side. Over here, the top is the parabola and the bottom is the parabola. While over here, the top is the parabola, the bottom is the line. The bottom function changed, you need a whole new integral when one of these things change. Okay? So first you want to know the main idea when you're talking about areas between curves. Top minus bottom or right minus left, and you sort of split things up to do which way is going to be easier for you. There are other times where the functions themselves are just too complicated. Maybe it might have been the case where it would have been difficult for me to write these functions in terms of x, and so you have to just bite the bullet and use two integrals and do it in terms of y. But you need to know that's what you're doing before you even start the problem. So because we had to do that quiz, we're out of time for the examples, but I'll write them on the board. I want you to try the examples. I won't consider the section finished, so the homework isn't due. But try these examples. We'll talk about them in tomorrow's class and then move on to inverse functions. And then the homework for that section will be due on Tuesday. Okay, so here are some examples I want you to try. Find the area between y equals x squared, the x-axis, and x between 0 and 2. X equals y squared, y equals x minus 2. C. Y equals 3 minus x. Y equals x squared minus 9. Okay, so try those for tomorrow, we'll run over them quickly and then move on to the next section. I also want you to consider an idea. Also consider. Is sketching absolutely necessary? See you guys on Friday.